Hello learners. Now let us see how to prove this statement, this equation with the help of mathematical induction. Guys, this took me a lot of effort, to make this PPT. So please listen till then. The explanation will be really good. Okay. Now, I kept the equation at the top so that you can refer to it anytime. Okay, you can refer to it quite easily. Now, if you'll observe in this series, the nth term is not given. The nth term is not given. So my first job would be to find out the nth term. Now, if you'll observe in the numerator of the first term, it's 1 cube. Second term, it is 1 cube plus 2 cube. Third term, it is 1 cube plus 2 cube. Okay, come here. It'll look easy. So you can assume. So basically, for the second term, it's ending at 2 cube in the numerator, and in the third term, it's ending at 3 cube. So likewise, for the nth term, it will end at n cube. My nth term is going to be in my nth term, the numerator is going to be 1 cube plus 2 cube plus 3 cube up till so until n cube. Fine. Now that is done. Wonderful. Now let's come to denominator. Here in the denominator, in the first term, my denominator is 1. In the second term, my denominator is 1 plus 3. In the third term, my denominator is 1 plus 3 plus 5. So basically, there are 3 terms. Like in the third term, there are 3 terms in the denominator. Now, if you'll observe, this is like a pattern. What is that pattern? This is 1 plus 3, 1 plus 3 plus 5. So basically, if you'll observe 1, 3, 5, next will be 1 plus 3 plus 5 plus 7. And so on, it will go on till 2n minus 1. My end term is going to be 2n minus 1. How? Uh, uh, because, if you see, if I'll put in 2n minus 1, n as 1, I'd get 2 times 1 minus 1, which is 1. If I'll put in 2n minus 1, my n as 2, so it's going to be 2 into 2 minus 1, which is nothing but 4 minus 1, which is nothing but 3. Or otherwise, you can also get it like you can take it as an arithmetic progression. Okay, 1, 3, 5, 7, dot, 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 and so on. You can find out the nth term using arithmetic progression. You will get it as 2n minus 1. Okay, so in the nth term, my denominator is going to be 1 plus 2 plus 1 plus, I'm sorry, 1 plus 3 plus 5 plus up till so on till 2n minus 1. So that's what my first statement is. The nth term of the given series is this. As I told you, my numerator is this and my denominator is this. Now, let's try to simplify this a little, okay? Why to keep it like this? You know that, sum of cubes of first 10 terms. Do you guys remember the formula? It's actually n square into n plus 1 whole square by 4. And this one, the formula for this is n square, okay? Sum of first n odd natural numbers is n square. Okay, so ultimately I'd get this. Okay, this would be nothing but n square into n plus 1 whole square by 4, and this denominator n square. So this will be multiplied with 4. I'll be getting something like this, n square, and would get cancelled, and ultimately I'm left out with n plus 1 square by n plus 1 whole square by 4. See, such a complicated one reduced to this. Okay. Now, I'm going to take the given statement as P of n. Let P of n be the statement. This. If you'll observe here, it's just given up to n terms. I found out the nth term. That's why I kept it going on up till n plus 1 whole square by 4. Okay, because that's going to be my nth term. And everything else is same. Okay, everything else is same. You can see the question as it is. It's just that, the nth term I found it on and I kept it like this, because if you'll find it here, it will be very easy down the line. Okay, you'll understand. Okay, now as you know, in mathematical induction, first you need, and also one more thing before going ahead, I'm going to take the sum on the left hand side. I'm going to take the sum on the left hand side as s of n. Okay, I'm going to take the sum on the left hand side as s of n as the textbook format. How it's given in the textbook, I'm using the same format. Okay, just write it as it is, you'll get full marks. Don't worry about it. Now, since now you know that we need to prove that the given statement is true for n equal to 1. So s of 1 you find, s of 1 would be nothing but just the first term here, 1 cube by 1. And in the RHS, here also you just keep 1, okay? If you'll evaluate, you'll get, since s of 1 is equal to this, that is 1 equal to 1, that formula is true for n equal to 1, okay? This is pretty simple and an easy statement. You need to show that the given statement is true for n equal to 1, okay? So hence we have showed that the formula is true for n equal to 1. Okay, the first part is done. Now the second part is that we need to assume that the given statement P of n is true for n equal to k, and comma k is greater than or equal to 1. Don't forget this. Okay, don't forget this. Okay, k is greater than or equal to 1. So my s of k would be nothing but this, equal to this. I did not do anything. See, S of n is nothing but this, which is equal to this n by 24 into 2n square plus 9n plus 13. If its LH is equal, it will be equal to RHS also, right? So therefore, in place of the given n, I just kept it as k. Okay, in place of the given n, I just kept it as k. So S of k would be equal to this. Okay, up to k plus 1 whole square by 4. There's nothing but equal to this. If you have any, I can just show you the. See, this is my initial statement. Okay, this is my initial statement. In this, I just put k. In place of n, I kept it as k. That's it. Which would be nothing but my S of k, because I denoted it like this. This the sum on the left hand side, S of k. Fine. And yeah, so that's why I'd get this. Okay. Now we proved that the given statement is true for n equal to 1. We assume that the given statement to be true for n equal to k. Now we need the real part. We need to show that the given statement is true for n equal to k plus 1. Okay. We show that the formula holds is true for n equal to k plus 1. From here, the explanation is going to be a bit critical, so please be attentive. Please be attentive. That is, we show that S of k plus 1 equal to this. How did I get this? See, S of k is nothing but this. Okay, S of k is k by 24 and 2k square plus 9k plus 13. So S of k plus 1 would be nothing but in wherever you see k here. Okay, wherever you see k here, I need to put it as k plus 1. I need to put it as k plus 1. So basically, I need to show that S of k plus 1 is. Now where to start? We'll start with the basic definition. What is my S of n? What is my S of n? My S of n is this 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3, like up till this. Now, what is my S of k? S of k is this. So what would be my S of k plus 1? A term more than this. Okay. What will be the next term of k plus 1 whole square by 4? It will be k plus 2 whole square by 4. Okay. My S of k plus 1 is going to be all these terms, everything, this sum plus k plus 2 whole square by 4. Okay, which is my basic definition. Okay, which is my basic definition, S of n, which I took, and from that basic definition I got this. Now if we know that this one 1 cube by 1 plus 1 cube plus 2 cube by 1 plus 3 and so on up till k plus 1 whole square by 4, there's nothing but S of k. There's nothing but S of k, and this one will be there, so there's nothing but equal to S of k plus 2 whole square by 4. Now if you guys remember, what was my S of k? S of k is equal to k by 24 into 2k square plus 9k plus 30. Yes, I'm going to write it down. Write that down. See, S of k, since S of k is equal to this k by 24 into 2k square plus 9k plus 13, my S of k plus 1 is equal to this. In place of S of k, I just put this plus k plus 2 whole square by 4. Now here on simplification will start. From here on simplification will start. Now multiply this k to this and expand this square. Okay. Okay, in fact, I did not multiply it yet. I just kept it as it is. I just expanded here a plus b whole square, a square plus 2ab plus b square. So k square plus 2k into 2 plus 2 square by 4. And this is k into this. Okay, I just made the denominator, like this, which because the format will look neat. Now multiply k to all the three terms. So here it will be 2k cube plus 9k square plus 13k by 24. And this will be 2k into 2 would be 4k. So k square plus 4k plus 4. Now here I have 24, here I have 4. So basically when I'll take LCM, I need to multiply here by 6. Okay, and here also by 6. So I'll get 6 times k square plus 4k plus 4 by 24. When the denominator will become same, you can just like write it like this here. Okay, now multiply the 6 to these three terms. So it will be 6k square plus 24k plus 24. That's what you're going to see it here. Okay, plus 24k plus 24. Now I'm not multiplying. Now add 9k square plus 6k square is 15k square. 13k and 24k is plus 24k is 37k and plus 24. This is what I have. Okay, now here there's an important point which you guys need to remember. What was my S of k plus 1 which I had to show? What was my S of k plus 1? It is k plus 1 by 24 into something. Okay, something in the bracket. That means for my S of k plus 1 is a factor. That means for my S of k plus 1 is a factor. I already know this by seeing that, because I need to prove it like this. I know that k plus 1 is going to be a factor of that, of my S of k plus 1. That means I got a cubic equation, right? If you remember here, I got a cubic equation here. For this cubic equation, it's not an equation, I'm sorry. For this cubic polynomial, k plus 1 is a factor. So what I'm going to do is I'm going to divide this cubic polynomial by k plus 1 so that I can get my quotient as a quadratic equation. Not a quadratic equation, quadratic polynomial. Sorry for that again. Now I'm going to divide this cubic polynomial by k plus 1 because I know that it will leave a remainder 0. It will leave the remainder 0 because it's a factor. K plus 1 is going to be factor. I know that it is going to be factor for this polynomial. So my quotient is going to be, I'm sorry, my remainder is going to be 0. Okay. Now here I'm going to divide it with synthetic division method, not the normal. You could use the normal method also. It's totally fine. If you feel the synthetic division method is going to be a bit tough with you, you could use a normal division method. But it's quite simple. Okay, I'll make it simple and I'll explain it also. Now listen. For synthetic division method, first make two lines like this. Okay, and then write down the coefficients in a systematic order. Like here, a k cube coefficient is 2 and k square coefficient is 15, k coefficient is 37, and here 24. It's already in order. Just put them down like this. Okay, 2, 15, 37, 20. Now I'm dividing this one by k plus 1. I'm dividing this one by k plus 1. So here there's plus 1. So right here minus 1. Right here minus 1. That's what the method states. Now begin with a 0. Put a 0 under 2. Put a 0 under 2. What is 2 plus 0? Here you need to do addition. Okay. What is 2 plus 0? It's 2. Now from here you need to do multiplication. What is 2 into minus 1? Minus 2. Put it here under 15. What is 15 plus minus 2? I mean basically 15 minus 2? 13. Now again multiply. What is 13 into minus 1? Minus 13. Put it under 37. 37 minus 13. What is 37 minus 13? It is 24. Now multiplies 24 with minus 1. Minus 24 I get. And 24 minus 24 is 0. If you do everything right here, you should get a 0. If you do everything right here, you should get a 0. Okay. If you're not getting, that means somewhere you made a mistake. You need to check the method. This would be nothing but a coefficient of k square. This would be nothing coefficient of k, and this would be my constant. Okay, so therefore this cubic polynomial I can write it as k plus 1 into 2k square plus 13k plus 24. Okay, this is totally acceptable. You can do it like this, or if you feel you want to do with the long division method, as I already said, you can go ahead. Therefore this cubic polynomial is nothing but equal to this k plus 1 into 2k square plus 13k plus 24. Now, so my s of k plus 1 would be nothing but this divided by 24. Okay, that 24 is already there. Okay, now if you remember, I got k plus 1 outside. If you remember, I had to show like s of k plus 1 as this k plus 1 into 2 times k plus 1 whole square plus 9 into k plus 1. You can refer here. Instead of n, there should be k plus 1. Okay, that's it. Now k plus 1 I got already. 21 is also there. Now here internally I need to change it so that I'll get 2 times k plus 1 whole square and 9 times k. It's very simple. Just a little bit a rearrangement. That's it. Now see this 13k, I'm going to write it as 4k plus 9k. Okay, 4k plus 9k. Why? Because I want 9 times k plus 1. And next I'm going to write this 24 as 2 plus 9 plus 13, because here in the end I need 13. I got 13, and then I will left out with 11. 11 split it with as 9 and 2, because here I need a 9 to get 9 times k plus 1, and here I need a 2. Now in these three terms, first three terms take 2 common, and these two terms take 9 common. Okay, if I'll take 2 common, I'll be left out with k square plus 2k plus 1, and then plus 9 into k plus 1. Okay, k square plus 2k plus 1, as you know, it is nothing but k plus 1 whole square. So hence, therefore, s of k plus 1 is nothing but k plus 1 into 2 times k plus 1 whole square plus 9 times k plus 1 plus 30. Yeah, I know it went along, it bit long. This is a bit big question. I also agree. This is a bit big and requires a lot of focus and attention also. Okay. Now some more statements to wind up. Therefore, the formula holds true for n equal to k plus 1. Okay. The formula holds true for n equal to k plus 1. I stated in the middle that, okay, I need to show that s of k plus 1 is this. Now I showed it also. Now after that, these are some lines. Therefore, by the principle of mathematical induction, because again to sum up the principle, I showed that the given statement is true for n equal to 1. I assume that the given statement is true for n equal to k, and prove that the given statement is true for n equal to k plus 1. Therefore, by the principle of mathematical induction, p of n is true for all n belongs to n. That is the formula. is true for all n belongs to n, means for all natural numbers, this formula holds true. That's it. Thank you very much. Not just this question. I'll be making many more questions based on mathematical induction in IP format. Okay. Already for some more questions, you can just check out the link given in the description. You will find some more questions videos. I'm still making. Okay, it will take some time, but some at least you will find. Okay, slowly the playlist will be updated. Right? If you like this video solution, please hit the like button. And if this is your first time coming across my channel, please do subscribe to it.